సరే ఆపేద్దాం రికార్డ్ స్టార్ట్.
Okay. Decision tree, right? Decision tree is an example for non-parametric learning. Non-parametric learning. Non-parametric learning. It means it does not assume the function. F of x function will not be there for the things, right? They do not assume function. They don't have the parameters. They don't have the parameters. Instead is point most important. Determine the structure, determines the, this underline this point, determine the structure based on the data. So this point you must understand this. They don't have the parameters, they don't have f of x function. Instead, they determine the structure based on the data. How the decision tree works. If somebody asks, you need to explain this way. You need to, this is very, very important algorithm. You need to explain core to the core. Decision tree learns by finding of best split in the data, each node. Point number 1. Point number 2. So for regression problem, what we used, Rohit? Regression problem, we are used variance.
Yeah, various reduction method.
Variance reduction method. For classification,
We use mode.
Another methods. Okay. See, unlike parametric models, where parameters are fixed and updated during the training. Updated during the training process. The decision tree determines how the decision tree works. Decision tree determines these things. One is split point for the future. Split points for the future. Second is tree structure. Third one is condition for branching. These three are major things while constructing a tree. What is this? Split point for a feature, tree structure, condition of the branching.
Sir, split point for the feature means which feature we need to select?
Yes, which feature we need to select?
Based on the variance only, right, sir?
Which feature we need to select? based on variance detection.
Okay.
Okay.
Tree structure means like what we need to construct binary search tree or something like that.
Rohit?
Sir.
I didn't get you.
Like tree structure means what kind of tree we need to construct or what? Yesterday we construct the binary search tree, right?
Tree construction means depth of the tree. Depth of
Okay.
a tree and number of leaf nodes. Number of leaf nodes. Okay. Yes or no?
Okay. Okay. We have to choose the tree which has less depth compared to other trees, like other methods.
We will see that hyperparameters. Okay. We
Okay.
will see that hyperparameters. For regression problem, what we are going to identify? Regression problem,
Average, mean.
we consider the mean of the leaf values. And then, okay.
Yes, sir.
Okay. Now, next point is as decision tree is non-parametric learning, we don't have the parameters. Okay. Hyperparameters. We have something called hyperparameters. What is this? Hyperparameters are parameters set before the learning process begins. Before the learning process begins. Before the learning process begins. The hyperparameters controls the structure and model control the structure of the model and behavior. Structure of the model and behavior. Structure of the model and behavior. Okay. Decision tree hyperparameters. Decision tree hyperparameters is maximum depth. What is this? మనం చూసాం కదా ట్రీ స్ట్రక్చర్ లో ఏం చూసాం రోహిత్? maximum depth. It is the maximum depth of a tree. It limits the number of splits to prevent overfitting. What is this, Rohit?
Overfitting.
Overfitting means what? Training is good and testing
is bad. ఇదే
Okay.
కదా సార్ నిన్న మీరు అడిగిన క్వశ్చన్.
ఇంకా ఉంది. Minimum samples in the split. Minimum samples split. This is the one more parameter. Important parameters. Write down this notes is very important. Minimum, we want to get a more idea, more entire thing. Minimum number of samples requires to split a node. To split a node. It controls the overfitting. Larger values leads to the simple trees. Larger values leads to simple trees. This point also you need to underline. Very, very important for interview process. You cannot directly say that I know decision tree. If somebody asks the decision tree, you should tell them that from the starting to the beginning, you have to have the content of half an hour. Content of half an hour. And minimum samples in the leaf. Minimum samples underscore leaf. The minimum number of samples of a leaf node must have. Larger values prevent small splits, improving of a generalization. Improving of generalization means solves the overfitting problem. Max leaf nodes. Maximum number of leaf nodes. Maximum leaf nodes limits the growth of a tree. Limits the growth of the tree by capping its complexity. Capping it. This is what most important. Okay. Splitting criteria. Splitting criteria for regression problems. For regression, MSC is nothing but variance reduction. For regression problem. You can also choose splitter. Option is what? Splitter. You can make as a best or random. Two options we'll have. Random. Best means choose the best split. And random means choose the random. Choose the random split. This is the most important question. Next question is why decision trees are overfit. Next interview question is very, very important question. Very important. If he don't ask this question, he don't know the AI. He don't know properly machine learning. Why decision tree overfit. ఇదే కదా క్వశ్చన్ అడిగింది రోహిత్ నేను, అవునా
అవును
కదా?
సార్, అవునవును.
వై?
Because depth of the tree.
డెసిషన్ ట్రీ ఫిట్ చేయడానికంటే ఎక్కువ మెమరీస్, ఐ మీన్ థింక్ చేయడానికి, మెమరైజ్ చేయడానికి ఎక్కువ ఉంటది. అందుకని ఓవర్ ఫిట్
Sir,
అయితది.
like one depth of the tree means like డెసిషన్ ట్రీ స్ప్లిట్ చేసినప్పుడు డెప్త్ ట్రీ యొక్క స్ట్రక్చర్ చాలా పెద్దగా ఉంటుంది సార్, డెప్త్ పెరిగిపోతా ఉంటది అనమాట. సో దట్ ఈస్ ఆల్సో వన్ ఆఫ్ ది రీజన్ ఫర్ ఓవర్ ఫిట్టింగ్.
ఓకే, ఫస్ట్ ఆప్షన్ ఇస్ splitting until pure. This is the first option. It means that decision tree continue to split node until either all data points belongs to same class. This is for classification. And the most important is the very, very important why it has been prone to overfit. The variance of the node is 0. The variance of node is 0. There is no variety of the data. Yes or no? And also second point is lack of constraints. What is this? Lack of constraints. See, by default, if we are not using any specific options like depth of a tree, maximum depth. If you are building default tree, right? When you are building a default tree, it won't have any constraints, right? Any restrictions. They grow, the tree grows very deeper. Rohit, as you said, right?
Yes sir, yes sir.
Very deeper. This will leads to the what? Overfitting. This point is very, very important. This point and this point is, these 2 points are very important.
Sir, like is there any rule that or like is there any assumption that we can fix the number of trees in decision tree?
Yeah, we
Like
can
how
fix. We can fix. Number of tree will be only 1 tree, right? Decision tree will be, number of trees will be only 1 tree.
like how we do in random forest, sir?
Random forest will be different. Okay. The third point is sensitive to the small variation in the data. Sensitive to the small variation in the data. Decision trees are very sensitive to the variation in the training set, training data. Small changes completely changes the splits. Completely changes the split. This is one problem. It will overfit on a small data sets. Overfitting small data sets. If you tell these many reasons, he will never ask the question. With the small data sets, model can memorize the training data. What it will do? Memorize the training data. Memorize the training data rather generalization. In this case, tree tend to grows deep and fit data too closely. This is also one of the biggest problem. Okay, next thing is that how do you prevent the overfitting? These are the reasons. How do you prevent overfitting? We know what are the reasons for overfitting. How do you prevent? One is pruning. One is what? Method is what? Pruning. Remember this, write down this, pruning. How do you do? Pruning means limit the pre-depth. 1 point, set the minimum number of samples required for splitting. Second option, set minimum number of samples at leaf node. Okay. And also you can restrict the features. Restrict the features by using max feature. You can take, if you have a 10 features, I can consider if it is overfitting, consider 7 out of 10 instead of 10. Use, if it is still overfitting, use ensembling method. Ensembling method is like random forest, gradient boosting, what it will do, it will aggregate the trees to reduce the overfitting. Reducing of the overfitting. How pruning helps? Reduce the overfitting, improves the interpretability, increase the efficiency. That's what. Clear? Yes, no, maybe.
Yes, sir.
Everybody. You need to by heart each and every point. Okay? Each and every point. Untold story of untold story of this. Okay. Now, second point is random forest hyperparameters. Random forest hyperparameters. Right. Random forest is a ensemble learning. What is this? Random forest is a ensembling learning. What it means, it will build multiple trees and results are gets aggregated. Results get aggregated. Results are getting aggregated. Then
Sir, aggregated means it will take average.
yes, it will take average.
Okay. Average from the overall the tree.
For all the trees.
All the trees. Tree specific hyperparameters. What are this? Maximum depth, right? Yes or no? Minimum samples. Sample split. Minimum samples leaf. And the max features. Maximum features. These are the tree specific. If you are building a decision tree, these are related to the decision tree. Agree or not agree? When we are talking about ensembling specific, ensembling specific hyperparameters. One is number of estimators. Naveen, what is number of estimator, Naveen? Number of estimators.
Number of trees.
Number of trees in the forest, right? More trees, generally improve performance, but increases the this point you need to understand.
Sir, it will not leads to overfitting. అంటే జనరల్ గా ట్రీస్ గ్రో అయితే డెప్త్ పెరిగిద్ది కదా సార్, డెప్త్ పెరిగినప్పుడు ఓవర్ ఫిట్టింగ్ కి ఛాన్స్ ఉంటుందా?
One second. Here the case is tree 1, tree 2. You are going to create number of trees. Idi, not the depth of a tree. Rohit.
Okay, got it, sir. Like how many trees it will be not matter because we are taking the average, right?
Yes.
Okay, got it, sir.
Second is bootstrap. Any idea, Navin, what is bootstrap?
So bootstrap is the sampling technique which we use in random forest, where we are taking the data points with replacement. So that we call as bootstrap.
Okay. Whether to sample the data with replacement for each tree. What it means? Navin, can you repeat the whatever the sentence?
So which means like sampling the data with it builds each decision tree with a sample of data with replacement technique, which means each decision tree will have a set of sample of data, so which can have same samples, like the samples can repeat at each data set, which means like entirely each tree won't contain all samples, but there are some data points which can repeat in each tree. So that way what happens, to earlier question, Rohit, right, you asked why if we have number of trees it won't overfit because each tree will have different samples of data. So that is what we call as bootstrap with a different number of features. So how many number of trees we built will have more information only. It will never tend to overfit.
Number of trees and different number of samples. And also some samples will have some common data. Right? This is the very, very important in the random forest. The interview question is that what is the important parameter in random forest is bootstrap. Okay. One of the most important question is OOB score. Out
Hello,
of
sir.
that.
Sir, 1 second. Hello, sir. Like, can you come again one more time, like with the bootstrap?
See, in random forest, features are different for each tree.
Yes, sir.
Data also will be shuffled across the trees.
Yes, sir.
And also the bootstrap will happen, right? Whether to sample the data with replacement of each tree. So when you do this, you will have some of the data is common in the trees.
Yes, sir.
Across the trees, so
Yes.
that all trees will learn perfectly.
Okay. So
Okay.
we will replace that common data.
Sorry?
మనం ఆ కామన్ గా ఉన్న డేటాని రీప్లేస్ చేస్తామా సార్?
Whether to see bootstrap అంటేనే కామన్ డేటాని రీప్లేస్ చేస్తుంది.
ఓకే.
Some of the common data ని.
ఓకే.
ఓకేనా?
Okay,
So,
అర్థమైంది.
Rohit, to just give you one example, let's say we have 1 to 10 samples for each
Okay.
tree. For first tree, we'll take 1, 2, 3. In second
Okay.
tree, we'll take 2, 5, 6, which means 2 is repeating in the second sample also. So
Yes,
that
sir.
is what we call with replacement. So generally, if we take sample, in every sample we'll have distinctive data 1, 2, 3, 4, 5, 6, 7, 8, 9, like
Okay.
distinctive data. But in case of bootstrapping sampling, we'll have data with replacement, which means in the second tree also 1, 2, 3 in first tree, 2, 4, 6, which means 2 is repeating in the 2 trees. Similarly, in the third tree also there is chance to have similar data sample of from first tree or second tree. So that is what we call with replacement. We'll take samples and create n number of trees.
ఓకే. థ్యాంక్ యూ అన్న. అర్థమైంది. థ్యాంక్ యూ సార్.
Okay. Out of bag error. What is this out of bag error? OOB. This is very important. What is this, Naveen?
So generally, as we discussed, right, when we build random forest, when we take the data samples with replacement, there is certain samples will left out, certain data points will left out. So that is what we call out of bag. So if you have 1,000 samples for building trees, there might be a chance 950 samples might be considered. So there is chance of 50 samples will left out. So these out of bag samples will use for evaluation. After building the model, we'll test our model in this out of bag sample.
Okay, out of bag error is out of bag error. You will get the out of bag error in random forest. It meaning of that the given data, whatever you are tested, given data, whatever you are testing, does not exist in any of the tree. Does not exist any of the tree pattern. So it will give us no sample is present in the training data set. No sample is present in the training data set. It fails to generalize. So that where we get out of bag error. And also the most important is number of jobs. What is this? Number of jobs. If you want to run the trees parallelly, not sequentially, we will use number of jobs equal to -1. Ante kada Naveen? -1.
Yes.
Yes or no?
Yes.
These are the story behind, the history behind the untold story of a trees. If you can understand this all dynamics, so you will be like any points missed, Naveen?
No, Suresh, I think you covered everything. Actually, this out of bag error or bootstrap aggregation techniques, all this is very important. You covered it very well. So I think we are good to go.
Okay. We will see the impact of each parameter on how this model performance. Naveen, when you start teaching, నాకు కొంచెం బాగా బర్డన్ అయిపోతుంది. 3 బ్యాచ్లు చెప్పాలంటే నాకు తల ప్రాణం పోకొస్తుంది. నవీన్, Huh?
Mostly, probably like whenever you are okay, I'm okay.
You will be okay, right? Okay.
Yeah.
First, we will see the impact of the. First, we will see impact of. Thank you so much. Impact of the maximum depth. Maximum depth in a decision tree. How this maximum depth will help us, right? Impact of a maximum depth from this is classifier. Okay. This classification. This is not. This is not the. We don't want to use the regret. We want to use the regression problem, right? Yes, and B. Import pandas as import C1 from sklearn learned data sets. Import make regression. Make regression sklearn tree, right? So import numpy as np. Now let us create the data set x comma y. Make regression number of features equal to 1. So what we are trying to do now here, it is x trained x test. Right. Colon 150. I have split the data into x and y. Okay. Plot a tree. Define plot tree effect. Tree effect with maximum depth is max depth. First, initially we'll make it as a none. We'll make it as a none. Then minimum number of minimum samples underscore split tree this was this. Now model dot fit predict y predict training data set. Train equal to regression dot predict y predict test, right? Train MSC mean square error, test mean square error, we will identify it. Now, what will identify? Plot the predictions. Plot the predictions. Plot the predictions. X underscore range equal to np dot linspace plt dot figure pick size equal to 8,6. Now plt dot training training data is, we'll make it as a color equal to blue, this color equal to red. Okay. Now we'll create this tree. Okay. Now we will call this function. Plot underscore tree effect maximum depth equal to 2. What is happening here? If it is maximum depth ainappudu, fit in the proper ga. Naveen, is it fitting properly?
It's trying to fit every data point. That's where it is trying to do. Like it is jiggling and trying to fit each of the data point.
Each data point. It is trying to cover all the data points. We will see maximum depth equal to 3. Now it is able to cover all the points, right, Rohit? Yes or no?
Yes, sir.
It is able to cover all the point.
Yes, sir.
Okay. Now, if I give maximum depth equal to none, what will happen, Rohit?
It
What
will
do you
not cover.
think? Huh? It is covering also, right?
Yes, sir.
It is also covering, right? Then we can also mention maximum to minimum samples. Minimum samples equal to 10. Okay. Here, maximum depth equal to 2, split equal to 3. Now you see, it is missing the points right here. Yes or no?
Yes, sir.
Minimum sample leaf. ఇక్కడ ఇంకోటి కూడా పెట్టద్దాం. మినిమం శాంపిల్ లీఫ్ ఈక్వల్ టు లీఫ్ లో ఎన్ని ఉండాలి అబ్జర్వేషన్స్ 5 ఉండాలి. అగైన్ స్టిల్ ఇట్ ఈస్ ఫెయిలింగ్. ఇఫ్ మాక్సిమం డెప్త్ ఇస్ నన్, now you can see it is able to fit, it is able to try, it is able to fit all the data, right?
Yes, sir.
Rohit, Shiva. Okay, what are the hyperparameters we have? ఈ కాకుండా ఇంకేమున్నాయి? Larger values. What will take? Maximum depth is larger values. Maximum depth, we will take larger. 10, what will happen? The maximum depth, right? It will overfit, right? Oh.
సార్ మ్యాక్సిమం డెప్త్ తక్కువ ఉండాలా ఎక్కువ ఉండాలా?
తక్కువ ఉంటే ఓవర్ఫిట్ అవుతుంది. Okay, now we will see that minimum sample split. Minimum sample
తక్కువ ఉంటే ఓవర్ ఫిట్ అవుతుందా? కానీ మనకి నన్ను వచ్చినప్పుడు ఏమీ లేనప్పుడు కూడా ఓవర్ ఫిట్ అవ్వలేదు కదా సార్.
ఒక్క నిమిషం. ఇప్పుడు ఇది ఒక కండిషన్. మినిమం వాల్యూ పెట్టినప్పుడు we will keep this a maximum value. At a maximum value అదేమవుతుందంటే అండర్ ఫిట్ అయిపోతుంది. 20, you would take 100 samples and the leaf minimum number of splits is 50 splits. Samples is 20. This one. It is also not properly working. So what will happen? The conclusion here, right? Smaller values. Smaller values like leads to overfitting. Overfitting. And larger values leads to underfitting. ఇక్కడ ఒక కండిషన్ రాసుకుందాంలే కానీ ఏముంది దాంట్లో. ఇక్కడ కండిషన్ రాసేద్దాం మనం కూడా. ఓకే, ఇప్పుడు ఏమైంది రోహిత్? లార్జర్ వాల్యూస్ కి స్మాలర్ వాల్యూస్ కి ఏమైంది? ఓవర్ ఫిట్టింగ్ అయిందా రోహిత్? ఓవర్ ఫిట్ అయిందా లేదా?
అయింది సార్.
ఓకే, లార్జర్ వాల్యూస్ తీసుకుందాం. ఈ లార్జర్ వాల్యూస్ తీసుకున్నాం కదా, ఇక్కడ మనం ఏమవ్వాలి? ఇప్పుడు అండర్ ఫిట్ అవ్వాలి. అంతేనా? ఇది కూడా ఓవర్ ఫిట్ అవుతుంది. ట్రైనింగ్ ఇస్ లెస్. ఇక్కడ కూడా
అసలు మాక్సిమం డెప్త్ వాల్యూ నన్ను పెట్టారు కదా సార్, అది రన్ చేయండి.
ఇది ఓవర్ ఫిట్ అయిపోతుంది. ఇది అండర్ ఫిట్.
ఓవర్ ఫిట్టే సార్.
అండర్ ఫిట్ రా. ట్రైనింగ్ ఇస్ నాట్ గుడ్. టెస్టింగ్ ఆల్సో నాట్ గుడ్. ట్రైనింగ్ బాగా అయ్యి ఎంఎస్సి తక్కువ ఉంటే ఓకే, అండర్ ఫిట్ ఓకే. హియర్ మాక్సిమం లీఫ్ నోట్ 20 పెడదాం. ఇప్పుడు
ఓవర్ ఫిట్ అయింది కదా సార్, ట్రైనింగ్ తక్కువ ఉండి టెస్టింగ్ ఎక్కువ ఉంది. ఎర్రర్
ఎక్కువ ఉండాలన్నా తక్కువ ఉండాలన్నా మనకి?
ఎర్రర్ తక్కువ ఉండాలి సార్, అప్పుడే మంచి పర్ఫార్మెన్స్ అయినట్టు. ట్రైనింగ్
ఓవర్ ఫిట్ అండర్ ఫిట్?
ఫిట్ అంటే హై అక్యురసీ ఆన్ ట్రైనింగ్ డేటా, పూర్ అక్యురసీ ఆన్ టెస్ట్ డేటా.
This is overfit or underfit?
This is overfit.
Overfit.
Okay.
Sorry, this is underfit. What we see is underfit.
This is underfit. Yes. Maximum values తీసుకున్నప్పుడు ఏమవుతుంది? Underfit అవుతుంది. Maximum value తీసుకున్నప్పుడు.
Sir, how sir? Like here, training error accuracy is lesser than testing accuracy.
Sorry. Yeah, true. Rohit, you're true. I am just going with the values, but yeah, error is less here. So this is overfit. So in training data, it is performing well, and in testing, it's not.
Like every graph is having only overfit.
ఒక్క నిమిషం ఆగురా, శాంపిల్స్ ఎక్కువ డేటా తీసుకుందాం.
సార్ అసలు ఎంతకీ ఇప్పుడు మాక్సిమం డెప్త్ అనేది ఎక్కువ ఉండాలా తక్కువ ఉండాలా సార్? కన్క్లూజన్ బుక్ కన్క్లూజన్
ఇప్పుడు చూడు అంటున్నా. ఓకే, ఇప్పుడు చూడు, పర్ఫెక్ట్ వచ్చిందా?
కొంచెం తేడా ఉంది.
అప్రాక్సిమేట్లీ.
అవును సార్.
మాక్సిమం డెప్త్ తక్కువ ఉంది. ఇప్పుడు మాక్సిమం డెప్త్ ఎక్కువ ఇద్దాం. మాక్సిమం డెప్త్ నన్ను ఇద్దాం. ఏమవుతుంది ఇప్పుడు? ఏమైంది ఇప్పుడు? ఓవర్ఫిట్
అయింది సార్.
ఓకే, మాక్సిమం డెప్త్ ఎక్కువ ఇద్దాం. ఏమైంది?
ఇక్కడ కూడా ఓవర్ఫిట్ అయింది సార్. సార్ అసలు లెక్క అయితే అక్కడ మీరు మ్యాక్సిమం డెప్త్ నన్ను ఇచ్చారు కదా, అక్కడే మనకి ఐడియల్ కేసు రావాలి సార్.
మాక్సిమం డెప్త్ నన్ను ఇచ్చినప్పుడు అసలు ఐడియల్ కేసు ఎందుకు వస్తుంది? మాక్సిమం డెప్త్ లేనప్పుడు ట్రీ గ్రో అయిపోతుంది కదా, ఓవర్ ఫిట్ అయిపోతుంది.
So Rohit, what happens if we don't give maximum depth? It will grow until last pure need. So it will go to the fullest. So when we want to restrict that, we'll give maximum depth. Let's say it can be 10.
అర్థమైంది అన్న. అవునన్న, నాదే తప్పు.
నీదే తప్ప? దీన్ని ఇంకా ప్లే చేయాలి. దీన్ని ఇంకా we need to do the experimentation. ఓకేనా?
Okay, sir.
Same way for random forest. We will see the effect on these with random forest. రాండమ్ ఫారెస్ట్ లో ఏం పెరుగుతుంది రోహిత్?
హలో సార్,
రాండమ్ ఫారెస్ట్ లో ఏం పెరుగుతుంది? ఏం మారుతుంది? నెంబర్ ఆఫ్ ట్రీస్.
అవును సార్.
నెంబర్ ఆఫ్ ఎస్టిమేటర్స్. Number of estimators 100. Max depth
100 trees grow అవుతాయా సార్?
minimum sample leaf from sklearn dot ensemble random forest regressor.
నాకు ఎందుకో ర్యాండమ్ ఫారెస్ట్ రిగ్రెసర్ కి బెటర్ రిజల్ట్స్ వస్తాయి అనిపిస్తుంది సార్ డెసిషన్ ట్రీ కంటే.
బెటర్ రిజల్ట్స్ వస్తాయి కాబట్టే తీసుకుంటున్నావురా. Okay, number of estimators equal to
10 పైన 10
10.
ఇచ్చారు కదా.
100 ఇష్టం పైన. ఏం నవీన్ ఇది? కదా. Okay. Number of maximum depth equal to 3. Now you see maximum depth equal to 2. Okay. Maximum depth equal to 1. Okay, smaller values you will get the better response.
Yes sir.
Better ones. This house, this random forest works on this random forest also. You can also maximum depth, you can play around with maximum depth and everything. So minimum sample leaf, you can make it as a 5 also. You can make the 5 also. Now you see?
Yeah, approximately బాగా వచ్చింది సార్.
బాగా వస్తాయి. Now you see 100 trees, maximum depth also you can make that 2 is a maximum depth. You can see the minimum values you will get the good amount of responses.
So basic difference between decision tree and random forest is the aggregation function అయినా సార్
Aggregation.
యావరేజ్ మీన్ తీసుకుంటది కదా సార్. ఒక మనం ఏ ఫీచర్ తీసుకున్నా కానీ ఏ ఫీచర్ చేయాలనుకున్నా కానీ టోటల్ ట్రీ కన్సిడర్ చేసిద్ది.
అంత టోటల్ ట్రీ కన్సిడర్ చేసిద్ది. అది మనకి అలా.
ఓకే ఓకే.
Okay. ఓకేనా, దిస్ ఈజ్ అబౌట్ ట్రీస్. క్లారిటీ వచ్చిందా అందరికి? Everybody got the, you can play around with this, you can play around with this. Okay,
okay sir,
see you guys tomorrow. Naveen, anything we missed?
నవీన్ అన్న లేడన్న వెళ్ళిపోయారు అనుకుంటా సార్.
Okay.